Hey folks, welcome back to the System Design playlist. So this is day 02 and today we are going to discuss about few important topics, which is we have latency. Then we are going to discuss about hypertext transfer protocol and hypertext transfer protocol secure. Also, we are going to discuss about what is API with the real world scenarios or practical examples. And in APIs, we are going to discuss about Open API. Then we have private API, and we also have code interface. So let's start with the latency first. Okay, in latency, whenever a client communicates with a server, suppose this is a client, and this is a server, right? There is always some delay. You face a delay when client sends a request to the server and the server responds back. There is some delay. One of the biggest cause of this delay is the physical distance. This entire distance that the request response cycle is covering, this entire distance is responsible for that delay. For example, you have this server situated in New York, and the client is requesting from India. The client is actually requesting from India. See, the request is going the way to the New York from India. So there is a very long distance, vast distance to be covered. This is request and this is the response. So this overall distance has to be covered, due to which we face a delay. And one way to reduce this delay is like you can do either by using multiple data centers, or you can locate the request to the nearby server. We also call it as a round trip delay. This also known as round trip delay. Why do we call it as a round trip delay? Because there is one complete cycle. As you can see here, there is a complete cycle here. If I talk about this, there is entire cycle, right? So this entire cycle is causing a delay, and that is why we call it as a round trip delay. So the total time it takes for data to travel between the client and the server. High latency can make applications feel slow. Due to high latency, applications normally feel slower and sometimes also unresponsive. Sometimes also unresponsive. This is the major cause that why we feel buffering, and why there is unresponsive website. That is because of high latency. And the way that I was speaking about, like we can divide the load to the multiple data centers. So let's say you are having a service, and you are deploying all the services on a particular data center. It is not feasible, right? This will surely cause us high latency or a delay. But if I say I have this service and I am just dividing it on multiple data centers. Here, there was a condition of overload. Here the load is divided, so the latency is itself reduced as the speed is increased. Speed is up and latency is itself reduced. Once a connection is made, how do clients and servers actually communicate? Have you ever thought about that? That is why we have the next topic, which is called Hypertext Transfer Protocol. Every time you visit a website or browser and the server communicate using a set of rules. These are basically set of rules or protocols. We call them as Hypertext Transfer Protocol. Hypertext Transfer Protocol. And this is for Hypertext Transfer Protocol. We have Hypertext Transfer Protocol Secure as well. That is why, like, most of the URLs you have seen, those starts with HTTP colon, then you have your domain name, or it starts with HTTPS, then you have your domain name, which is the secure version. How actually it works? Have you ever thought about it? So let's move to the next slide. Here is how it works. You have a HTTP request here. If I talk about this, let's say this is a client. This is the actual client and this is a server. Client is sending a request to the server. This is a request. And then server processes the request and it generates a response, sends back to the client. When we are sending the request, it is actually termed as Hypertext Transfer Protocol request, HTTP request. So let's say what you are doing is you are sending a GET request, which is nothing but a request to fetch a HTML page, which is index.html, which is already stored on the server. And what information along with that you are sending is host name, which is, let's say, www.example.com. And you are also sending the user agent. User agent, like you have Mozilla, else you have Chrome, or any browser that you use. Also, we are sending the information like cookies, which includes the session ID, as you can see here. And then after all these requests are successfully sent to the server, server processes the request based on the information and generates a response. Here we have a response, like we have HTTP response. So we have HTTP status code. Here 200 is a status code. OK means that your request has been successfully accepted and a response has been generated. We have a content type. If we talk about the content type, it can be a text, it can be a HTML file, and then content length. HTTP has a major security flaw, like it sends data in plain text. That is a major security flaw. Let's talk about it. So HTTP sends the data as a plain text. This is a serious problem, like especially for sensitive information. You have passwords, or you have the credit card details, or you have details like you have your personal data. These are all sensitive information. We don't want to share them. That's why, like, modern web applications, websites use Hypertext Transfer Protocol Secure. They use HTTPS. That is the major reason why we use Hypertext Transfer Protocol Secure. HTTPS encrypts all data. What it do is, like, it encrypts the data. What it is using the secure socket layer. SSL stands for secure socket layer, and it is using a TLS. These are the secure layers which it is using for encrypting the data, ensuring that even if someone intercepts the request, they cannot read it, and they cannot alter it, means they cannot modify the data. A hacker or a cracker will not be able to modify the data. But client and servers don't directly exchange raw HTTP request and response. HTTP is just a protocol. It is just a protocol for transferring data, but it doesn't define, like, there are some terms which HTTP doesn't define. Let's talk about them. What HTTP doesn't define is like how your request should be structured. Okay, and if I talk about what format response should be there, what format response should be there, and if I talk about how different clients should interact with the server, let's say you have client 1, client 2. Client 1 has a specific permissions, whereas client 2 has some specific permissions. So how they are interacting with the server, let's say we have server 1 and both of them are interacting with the same server. So these all things are not decided by the hypertext transfer protocol or hypertext transfer protocol secure. This is where API or application programming interface comes in. Let's talk about that. So we have the API. Now, API stands for application programming interface. It stands for application programming interface. Think of an API as a middleman. You can think of an API like a middleman. We have middleman that allows client, like you have web mobile applications, to communicate with servers without worrying about the low level details. You don't need to worry about the low level details exactly, because I don't want to see how it is working. I just want to use the API. Almost every digital service that you use, these all are built upon the APIs. At its core, an API is just a bunch of code. These are a bunch of code which are working behind the scene that takes an input. Here we are providing some input, and API processes the input and produces an output. In simple terms, in layman's term, and these output are not 100% correct. These are predictable. So it is a kind of middleman that enables applications to interact without needing direct access to each other's code or database. Almost every digital service that you use, if we talk about um, every digital service, let's say we have a social media platform, then you have e-commerce platform, or you have a banking service. Every digital platform is using APIs behind the scenes. For example, we have if I take an real world scenario, so we have a weather API, right? And how the weather API is working, if you provide a city name as input, you are providing input, and in the input you are providing name. Let's say you are providing Delhi. Okay, and the API returns the current temperature. What it is returning is it returns the current temperature. It is also returning the what is the condition of the climate, humidity, let's say, and it is also returning the weather condition. Let's take another example which we have. Let's take another example. Let me clean this. So we have one more thing, which is Uber Ride API. If I talk about the Uber Ride API, how it works, if you provide a pickup and destination address, what you are doing is you are just providing a pickup and the destination address. And the API works behind the scene. The API finds the nearest available driver. It finds the nearest available driver. And then the API also calculates the estimated fare, estimated cost based upon the distance and availability, estimated cost. Let's take another example, which is Python. So let's take another example. Okay, we have Python's sorted API. You might have used the sorted function of Python, sorted method. If you provide just a list of numbers, like what you provide is you provide a list of numbers, let's say 5, 3, 8 and 1. You are providing this list of number as an input, and the API returns a list of sorted 1, 3, then you have 5, then you have 8. So it is providing you a sorted one. This is sorted. This is also an example of API. When engineers build APIs, they clearly define like what the input API accepts. It clearly defines what the input should be and what the output should be. They clearly define the format of accepting the inputs and producing the output, which ensures like consistency behavior across different applications. APIs follow a simple request to response model. They just follow a simple request to response model. Like we have this API. So you have this client is sending a request. This is a request, and then your API is going to interact on the behalf of the client to the server. Server is going to produce a response sending to the API. Then on behalf of server, API is going to generate a response sending back to the client. So this is how it is actually working. A client can be anything, like you have web app, you have mobile app, makes a request to the API, and the API is actually hosted on API server. Let's say this is API server, and this is a client. This is actually the client. It can interact with any necessary services behind the scene, like if you are fetching any details from the database, it will interact with the database, or if you are uploading something, it will interact with the database for uploading the data and saving the response there. The API sends back to the client, like you are just requesting it, and then we have a specific format for response. We have JSON, either JSON or we have XML. These are structured formats, and let's talk about the type of inputs. Every API requires a specific type of inputs. Every API requires like specific type of inputs, and passing incorrect data can result in error. If you like what format is already specified, if you are, let's say you have a Google Maps, and you are providing a string, and in this string you are providing your name, so it will produce an error. It will not show you anything. But if you are providing the correct location using the pin code, using the area code, and using the street name, so it is going to give you the exact location which you are searching for. Some APIs also requires inputs in a specific format. Example, the currency exchange API. Let's take an example. We have currency exchange API. So these have specific format. How these have a specific format? You can only provide, like, you can do either USD to INR, or you can do INR to USD, and so on. APIs often validate inputs. These often validate the inputs. It is going to check first whether the input is according to the format already specified. If the input is not according to the format, it is going to block that request and throw an error. So it helps in maintaining the accuracy and also security. Let's say there is some hacker or some threat to your device, and the threat is going to send a malware or a buggy code to corrupt your system. So API is going to check whether this format is matching. If this format is not matching, it is invalid, and it is going to generate a error. This is how it is more secure. Let's talk about the outputs. For example, the Google Maps API. You have the Google Maps API, which always returns coordinates in the same format. This is the format. When you type any string, it is not actually returning anything like a string. It is actually returning the latitude and the longitude. If the API cannot find the location, it provides an error, as we have already discussed about this. Like if you are going to provide a wrong input, it is throw you an error. It is going to throw you an error, like invalid address format, and you are going to receive a status code. This is a error code. I hope you got my point. Now let's talk about how APIs actually power the apps. The apps you use every day, whether it is Gmail, you use Gmail, and you have Instagram. Also, we use Uber or Spotify. We use them every day. These are essentially a collection of APIs. Behind the scene, these are also collection of APIs with a polished user interface on the top. So what is happening is, like, on the top layer you have a user interface. Behind that, API is actually working, but the user is first going to interact with the user interface, which we call the client, or you can say the end user. They are going to interact with the user interface, then user interface is going to interact with the APIs. Behind the scene, APIs are working. Most applications follow this front-end back-end architecture. Here we have the user interface, which is the front end, and this is actually working behind the scene, which is the back-end architecture. If we talk about the back-end, we have a front-end back-end architecture. So if I talk about the back-end usually consists of the APIs. APIs are in the back-end, right? And you have like You have data processing, you have business logic, you have communication with data, etc. And the front end is actually the graphical user interface that interacts with these APIs and making the applications user friendly and accessible without require users to write the code, right? Let's look at an example. So here we have this front end. Front end is usually the graphical user interface, GUI. This is the graphical user interface, and then this front end is going to interact with the APIs. Actually, here we have the API. The front end is going to interact with the API. It is going to interact with the API. So we have three API. Let's say in the backend we have three kind of API: find the nearby driver, request a ride, and process the payment. These are different APIs which are working at the backend. So let's understand more about this by taking an example of Uber. Let's break this. I am going to take an example of Uber. So let's first talk about the backend. Before the Uber app existed as a sleek and user-friendly interface, the company first built the core APIs that power ride-hailing services. Company first built the core APIs. And if I talk about what actually the core APIs were, so we have find the nearby driver based on the location of consumer, find the nearby driver, and we have API like calculate the cost and check the route, shortest possible route. Then we have process payment. Also, we have real-time tracking. Then we have matching the rider or driver. These are sort of APIs, which is this is number one, this is number two, this is number three, this is four, and this is five. These are the sort of different APIs which is working behind the backend. These APIs are actually running on Uber servers, forming the backend infrastructure. Every time you request a ride, track your driver, make a payment, these backend APIs handle the request. All these, like when you request a ride, so it is first going to find the nearby driver, then it is going to calculate the cost, then you are going to make a payment, then you are going to do the real-time tracking that where actually the driver is. You are also going to check the matching with the rider or the driver. Backend engineers are responsible for optimizing these APIs. Backend engineers are actually responsible for optimizing these APIs. Improving ride matching algorithms, securing transactions, and ensuring a smooth experience for millions of users. Now let's talk about the front end. So the backend APIs handles all the complex logic. That is clear, but they only work through code. The backend is actually working through the code, which isn't practical for everyday users. Like I cannot provide the JSON response or XML response to the end user. That is why companies build a front end. We have the front end, which we also call as user interface, right? And on the top of these APIs, allowing users to interact with the system visually and intuitively. So we are creating a graphical user interface through which on the top of API, user is going to first interact with the user interface. Then user interface is going to convert that in API understandable form, then actually behind the scene APIs are working. Let's take an example. If I talk about an example, we have like when you enter your pickup and destination address, the front end sends an API request to find nearby driver and displays available car. What you are providing is in the input, you are providing the pickup and the destination address, right? And in the input, when you provide this pickup and destination address, the API request to like one of those, which is find the nearby driver, to find the nearby driver, and it displays the available cars as output. It is going to generate an output and displays all the available cars on the user interface. So let's say you have this user interface. It is going to list down all the available cars on this user interface and the driver name along with that. Once the trip is complete, the front end may call the payment API. Once your trip is complete, front end will call the payment API to display the receipt. So you can see the receipt over the user interface once the payment is done. Now let's move further. Let's talk about the types of APIs. APIs come in different forms. These depends upon like who can access them and how they are used based on the scenario of usage, how they are actually used, and what actual purpose they serve, what purpose they serve. On behalf of these, we decide the types of APIs. So the very first type is open API. We also call them public APIs. Open APIs are accessible to external developers. These are easy to access to the external developers. And these have very minimal restrictions. Companies provide these APIs to encourage third-party developers. These are basically to encourage the third-party developers. Like I am a third-party developer. Here I am a third-party developer who is just starting. Let's say I am doing my personal project and I want to use API. I don't want to code them. So what I do is like I request to a company to provide me API. Let's say Stitch API, and with the help of this Stitch API, I am going to do the login, sign up, and all the things like registration. We have registration, we have role based access control. So I am going to do all these things using these API. I don't need to write the code. I'm just going to use the API. So we have the example of YouTube data API. Normally when you use the YouTube app, it makes internal API calls. When you use the YouTube app, it actually making the internal API call. To fetch your video feed, like it can have multiple APIs, which can be a fetch the video feed, or it can have an API like search for a content, and you can have so many other APIs like you have one more API, post comments, like, dislike, subscribe. These all are different kinds of APIs. YouTube also provides a public API that allow developers to access some of this functionality outside of it. Now, how YouTube provides a public API? They provide a public API, and let's say I am making a website. I am making a particular website, and on this website, I want to show the YouTube videos to be running. So I will not sit and write the code for that. Behind the scene, the YouTube API is working and it is generating a response which I can show to the users on my user interface. That is the beauty of public API. Let's take another example. We have YouTube search API. We have YouTube search API, and which allows developers to fetch video results based on a keyword. So if you are sending, like you are sending machine learning tutorial, you are sending this to the API, right? And API is going to search it, and it is going to prepare a structured response. It can be in JSON format, it can be XML, whatever else, containing a list of relevant videos, which may include the title. Then it can also have like description. It can also have thumbnail, and further we have the video links. So these are all stuffs going behind the scene. This is incredibly useful because it enables developers to build custom applications on top of YouTube. Now let's talk about the second type of API, which is internal API. We also call them as private APIs. Internal API is nothing but behind the scene. We also call them as private APIs. Internal APIs are designed exclusively for internal use within an organization. Unlike open APIs, these are not accessible to external developers. So these are not accessible to the external developer. And these are used to facilitate seamless communication between different internal systems within a company. Let's say you have a HR department, and within your organization you are also having a technical department. So both departments are going to interact with each other using different kinds of API working behind the scene. These are internal APIs. So let's take an example, which is a practical example of Amazon. Let's talk about it. So if we talk about Amazon, when you place an order, here you are, and you are going to place an order, right? While you place an order, you might assume that a single system processes your request, but that is not the reality. In reality, multiple internal APIs are working. Like there are multiple internal APIs. Let's say one is your order processing. And if I talk about, let's say there is another API, which is inventory. Let's say there is third API, which is payment. Let's say there is another one, which is tracking. These all different APIs are working behind the scene. These work together behind the scene, fulfill your order efficiently. So for this single order, these all APIs are working behind the scene in Amazon, let's say. Each of these APIs operates independently. So this is working itself and this is working independently, but they communicate through well-defined protocols to ensure a smooth and efficient communication. Let's say the order is already processed and now the order is sent to the inventory, and now we are checking whether the order is already available in the inventory. If it is available to the inventory, then the consumer is going to make a payment, and then if the payment is complete, then the consumer is going to the logistics department and going to track the status of the order. Internal APIs allows companies to break down their application into smaller manageable services, making it easier to scale. Developers can also reuse internal APIs across different projects, like it can reduce duplication. It can also reduce the duplication, and it can speed up the project. Now we have the third type of API, which is code interfaces. The first two type of APIs, as we discussed, the open API and internal API, are functional and serve real world use cases like fetching weather data or booking a ride. But there is another category of API that developers use daily, which is code interfaces. Code interfaces are also known as, we also call them library API, or you can also call them programming API. These APIs do not connect different applications. Instead, they provide predefined functions within a programming language or framework to make development easier. These provide built-in functions. Let's take an example. This is Python's built-in list API. This is Python's built-in list API. When you work with the list, Python provides a set of built-in functions, which we also call as methods, to manipulate the data. So like you have number, you are providing numbers, and then simply you are doing numbers dot sort. Here you are doing numbers dot sort. That is nothing but an API call to sort the list, right? And you have, let's say, fruits, a list of fruits. So you are doing fruits dot append, and you are going to add orange at the end. So this is also another API call to add an element. This is also another API call to add an element, and you are doing fruits dot pop. Then what pop is do is like it is going to remove the last element from the list. So API call to remove the last element. These are sort of different APIs which are already stored in the built-in functions. Instead of writing sorting algorithms from scratch, like developers can use the sort. They can use the sort simply, or they can use sorted in Python. Code APIs are not just limited to built-in programming languages functions. For example, TensorFlow. TensorFlow is an AI/ML library. So if I talk about TensorFlow, it is used for the AI/ML. That is the AI/ML library. It provides a high-level API for training machine learning models without needing to implement complex mathematical operations from scratch. Let's take its example. Now, if I talk about making the neural networks, so I don't need to write a lot of code for making the neural networks. I can simply use TensorFlow's API. I can simply use import TensorFlow as TF model, and this is the code for the API, and I don't need to create it from the scratch, because programming APIs is quite difficult. It is quite time taking. So we directly use the built-in APIs. Now let's go further with the discussion. API communication methods. Now, if I talk about the communication methods, API communicate using different protocols and architectures. We have different protocols and we have different architectures, right? That define how request is sent, how response are formatted, and how data is exchanged. How the request is sent, how your response is formatted, and how actually the data is exchanged. Based on these, we have the first category of API communication methods, which is REST API. REST API stands for representational state transfer. This is the definition. REST is the most widely used API communication method today. It is lightweight. If I talk about the features of REST, it is lightweight. It is stateless. Also, some more features like it is more scalable, making it perfect for the web services and mobile applications. REST APIs follow a set of design principles and use hypertext transfer protocol methods. These use hypertext transfer protocol methods. Like if I take examples, we have get, we have post, we have put, and we have delete. These are to perform specific operations. REST APIs are based on resource, so these require resources, and each resource is accessed through a URL. These all resources are accessed through a URL, which is the endpoint. The API follow the client server model. REST API also follow the same client server model, meaning the client sends a request and the server processes it and sends back a response. Let's take an example of REST API. Here we have a bookstore. We have to retrieve a list of books through get request. So we are actually sending a get request, and in return what we are getting is we are getting a response which is in JSON format. It is in JSON format. This is the syntax. So in response, what it is giving me is the ID of the book, and then it is providing me the title, which is like clean code, for example, and then author name. Again, there is another book. We have ID, we have the title, and we also have the author name. This is how the REST APIs work. Let's talk about another method, which is SOAP. SOAP stands for Simple Object Access Protocol. SOAP is an older API. This is the older API. Nowadays we use REST. This is basically based on XML based messaging. Unlike REST, which is lightweight, SOAP is more structured and more secure. It is more structured and secure, making it ideal for like what we normally do is we majorly use SOAP for banking, and we also use SOAP for healthcare, and we use it for enterprise. SOAP messages are sent using XML format. These uses XML based format, and it requires a WSDL. WSDL stands for Web Service web service description language. It is a type of file which defines the API's available functions and request structure. So what it includes is WSDL has like either it has login, or you are generating a session, and then like if you are doing logout. So these are already set in this WSDL, web service description language, and it gives based upon the requirements. Let's take an example of a banking service. How SOAP API works for a banking service. We have a request. This is the request. So we have to fetch the account balance. Here you have the syntax of the SOAP envelope. Then you are going to send the bank, like you are going to send the example of the bank, what you want to do. You have a header file here, and then you have a body, and what you are doing is you are providing the account balance, what balance you are going to receive, and then you have your account number here. Then you are closing the body and the envelope. This is the entire structure of the SOAP body. So this is for the request part. Let's move to the response. If I talk about the response, what you get is you get account balance response. So it returns a number, like let's say you have 5,000 in your balance, and this is the main body. If I talk about the main part, and then we have another API method, we call it as GraphQL. GraphQL is an alternative to REST that allows client to request exactly the data they need. So you are requesting for a specific one, and it is calling all the APIs, which we don't need. We need a specific request to be processed. You can request exactly the data you need. So you can request exactly the data you need, and making it more efficient for modern applications, unlike REST, which requires multiple API calls to fetch related data. GraphQL can fetch all necessary data. It can fetch all necessary data in a single request, instead of predefined endpoints. Like GraphQL exposes a single API endpoint. It has a single API endpoint. And the client sends queries to request specific fields. Let's try to understand this more well using an example. So we have an example, like what you have to do is you have to fetch a user's profile and their recent post in a single request. What you have to do, you are going to fetch the user profile and all of their recent post within a single request. You mention the user ID, you mention the user name, you mention the user email, and you mention the post title and the likes. This is a request. This is a request. These are all details we are providing in the request. And then we have a response. In the response, in the data, we have the user, and let's say we have name Alice, and we have the email of the user. Here we have all the post. Within a single shot, I am getting all the posts like hello world 100, then you have GraphQL is amazing. All the things I am getting within a single shot. This is how that's the beauty of GraphQL, that I don't need to request again and again for the same thing. Like I am requesting for a post, and then again I am requesting for the second most popular post for any celebrity. So I am making the API calls again and again. That is not the requirement. Last but not the least, we have gRPC. So what gRPC stands for? It is Google Remote Procedure Call. Google Remote Procedure Call is a very high performance. It is a very high performance and API communication method. High performance API communication method. It uses protocol buffers. We also call the protocol buffers as protobuf. Instead of JSON or XML, which makes it faster and more efficient, it doesn't use the JSON response and it doesn't use XML response. If I talk about the Google Remote Procedure Call, it uses binary data format instead of text-based format. Like it reduces the payload size and supports bidirectional scheming. It supports bidirectional streaming. You can do both the request and response at a time. It is bidirectional, so it is not taking any extra time. That is why it is quite fast, meaning the client and server can send the data at the same time. You have the client, you have the server, you are sending the request and response. These are taking simultaneously at the same time. This was all about the discussion for today. What we have covered today, we have discussed about what is API and what are the types of API. We have discussed about hypertext transfer protocol. We have discussed about hypertext transfer protocol secure. What is the difference between them? Okay guys, this was all about today's lectures. So I hope you like this video. Do like, share and subscribe my YouTube channel. Let's meet in the next video. Till then, take care, bye and thank you. Also have a happy Diwali. Stay happy, make everyone happy.